Hi students. So in this lecture you are going to see basic concepts regarding chapter electricity in your grade 10. This is 12th chapter in science and one of the chapters in physics, electricity. This material I have downloaded from tiwariacademy.com. You can also download this material and you can check all these concepts if you want to read those concepts. So let us start. Here I don't want to go into deep, just I'll brief the concept, and here you don't get a lot of concepts. So first we need to start with the topic charge. What is meant by charge here? Charge is a fundamental particle in an atom. You know, in an atom there will be three types of charges: negative charge, positive charge, and neutral charge. Negative charged particles are known as electrons, positive charge protons, neutrally charged neutrons. So it may be positive or negative or sometimes neutral too. And we have learned some properties of charges in our 6th, 7th classes. Like charges repel each other. So if you keep negative charged particle and negative charged particle like charges, what will happen in the sense? These two charges will repel. Same, if you take positive charge and positive charge, both charges will repel because of the same charge. Unlike charges attract each other. If you take one positive charge and negative charge, definitely both charges will be attracting each other. And charge, we can calculate, we can measure the charge. So whatever it may be the physical quantity, if you can able to measure it, definitely for this physical quantity, there will be unit. And SI unit of the charge is Coulomb, represented with capital C. So that is SI unit of charge. Now, what is that 1 Coulomb? It is quite easy to understand. You know what is meant by 1 kg. 1 kg is nothing but 1000 grams. Simply to say, what is meant by kilo? Kilo means it is count of 1000. Kilogram means 1000 grams. Kilometer, 1000 meter, like that. So kilo means count of 1000. What is meant by dozen? Dozen is count of 12. Same like that, 1 coulomb means count, number. What is that number means? In 1 coulomb, nearly 6 into 10 to the power of 18 electrons will be present. So if you take group of, count of, number of electrons, what should be that number? 6 into 10 to the power of 18. So if you take that much electrons, it is known as 1 coulomb. In electricity, it is not that much easy for us to say 5 electrons, 8 electrons, 25,000 electrons, because charge is very, very less. So here we are considering 1 coulomb. Next, here you see electron has negative charge. So what is the charge on one electron? It is negative charge of, simply to say, minus 1.6 into 10 to the power of minus 19. So if they ask what is charge of proton, you can say it is plus 1.6 into 10 to the power of minus 19. What is the charge of neutron? It is 0. Like that, you have to take charges of these. Negative charge electron minus 1.6 into 10 to the power of minus 19. Here you see guys, we have a formula. Q is equal to N into E. What is that Q? Q is nothing but charge, total. So total charge of the body, total charge of the matter you will take, and that charge is represented with the letter Q. Guys, here C is represented Coulomb. Coulomb is represented with the letter C, that is SI unit of charge. Here you see guys, don't get confused. physical quantity is charge, its SI unit is Coulomb. Charge is represented with the letter capital Q, and this SI unit COULOMB, Coulomb, is represented with the letter C. So Q is physical quantity, that is charge. N stands for number. E stands for charge of electrons. So N stands for number of electrons. E stands for charge of electron. So if you do it, you will get that Q, charge, 1 Coulomb. Next, this is the starting concept in your textbook. Current. Current is represented with the letter I. So till now we have seen few symbols. Q stands for charge, C stands for Coulomb. Now I stands for current. What is meant by current? If they ask you for 1 mark or 2 marks, you can say the rate of flow of charge. Simply to say, amount of charges flowing in a conductor in 1 second. Consider we have one conductor. Whatever point you want, you can take. For example, this is the point you can take. You see, this is conductor. We know conductors will have free electrons and all electrons will be flowing in the conductor. If you take this area or this point, how many electrons are crossing that point? So consider this is one point and we have n number of electrons here. So how many electrons are crossing this point? If you calculate, that is meant by current. You see the rate of, in 9th class already have learned rate of change of. Rate of means in denominator you will get a time, means in certain time. Flow of charge, so in certain time, how many charges are flowing? So simply to say, in 1 second, this time in 1 second, how many charges are flowing? If you calculate, if you measure, that is nothing but current. So we got formula I is equal to Q by T. If anyone asks you what is meant by current, you can say total number of charges flowing in a conductor in certain time or in unit time. In 1 second, you can consider this is the point, or you can consider this is the point, you can consider this is the point. From this point, how many electrons are crossing in 1 second? If you measure, that is current. Current is represented with the letter I, and we have got formula I is equal to Q by T. Q stands for charge, T stands for time, and in simple definition you can say number of charges flowing in 1 second. In a conductor, number of charges flowing in 1 second, if you calculate, that is current, and the formula I is equal to Q by T. Guys, already I told you, whenever you have physical quantity and if that physical quantity is measurable, for every physical quantity there will be certain unit. By seeing this unit only, you can say physical quantity. For example, if I say 60, simple, just I am saying only one number, 60. From that 60, from that context, what can you get? You can't get any answer from that because I have given only number to you. But if I say you by showing me, and if I say you 60 kg, now can you say the question? Yes, it is quite easy, right? What is the weight? 60 kg we can say. Now just I will show me, and now I will say 103. Just I will show me. I will say okay, 100. I'll show. I'll say 100. From this 100 context, what can you get? You can't get anything because I didn't mention any unit here. If I mention kg, you can say what is my weight? Okay, what is your weight? Like that you can ask a question. If I mention 100 degree Fahrenheit, now you can change your question, right? What is your body temperature? So if I say 100 kilometer per hour, you can say what is your speed? Like that, you see, just by changing these kg, Fahrenheit, kilometer per hour, you are saying about the physical quantity. So simply to say, what is meant by unit which will represent physical quantity is a unit. Now physical quantity is current. What is unit of current? It is ampere. Ampere. Here you can observe S unit of current is ampere, which should be represented with the capital letter A. Now, this ampere is a scientist name, so that we should not go with plural. Whenever you are seeing 1A, you have to say it is 1 ampere. Whenever you see 2A, don't say 2 amperes. Instead of that, you can say 2 ampere of current. If you see 10A, you can say 10 ampere of current. Don't say 10 amperes. So physical quantity is current. Yes, current you can measure. So if you are measuring, there will be unit. Because of measuring only, you can say 1 ampere current is flowing in a circuit, 2 ampere current is flowing in conductor, like that. So we have formula I is equal to Q by T. What is the SI unit of current? Ampere. 1 ampere is equal to, what is the SI unit of charge? Coulomb. 1 coulomb by, what is SI unit of time? Second. 1 second. So you have formula, at the same time you have this one. You see, current I is equal to amount of charge flowing in 1 second, that is time. Current is 1 ampere is equal to 1 coulomb by 1 second. So from this, what can you guess? So if they ask you what is meant by 1 ampere, you can say 1 coulomb of charges flowing in 1 coulomb of charge flowing in a conductor in 1 second. So just in 1 second of time, if 1 coulomb charges, 1 coulomb means how much? Here you can see 6 into 10 to the power of 18 electrons. If it is flowing in 1 second, you can say it is 1 ampere of current. Of course, you have some conversions. 1 ampere, MA stands for milliampere, mu A stands for microampere, NA stands for nanoampere. If it is capital MA, it is mega ampere. You have some conversions, but in 10th class, it is not that much needed. You can leave it. And I told you current you can measure. Current can be measured by using a device called ammeter. Ammeter. And always that ammeter should be connected in series. Always ammeter should be connected in series, because it has very low resistance. If you connect in parallel coil, it cannot tolerate it. So that always ammeter should be connected in series. Now this is most important point, direction of current. Direction of current is taken opposite to flow of electrons, as electrons were not known at the time when the phenomena of electricity was discovered first, and current was considered to be flow opposite charge, flow of positive charge. So simply to say, if you take a circuit, for example, you can observe this is one small circuit cell, and this is closed one. I did not connect any resistor, I did not connect any bulb. Now if you want to mention direction of current, this is positive terminal, big line, small line is negative terminal. Always current you have to represent like this, simply to say current is coming out from the positive and it is flowing to the circuit, and it will come towards negative. So arrow mark and I, like that you have to represent. Basically, charges will flow from negative to positive. Here don't get confused. If they ask you what is the direction of charges, charges means negative charges, always negative to positive. If they ask what is the direction of current, guys, this is direction of charge is from negative to positive. Direction of current is positive to negative. Don't get confused. In examination, always you have to concentrate on this direction of current, not direction of charges. So you can leave this, but try to remember. But in examination, don't go with this concept. Next, potential difference, simply to say it is voltage. So we need to learn about voltage now. Till now we have seen what is meant by current. Now voltage. Current is represented with the letter I, and while coming to voltage, it is represented with the letter V. Voltage you can also say as potential difference. In very simple words, guys, in cell, if you observe, there will be one positive terminal, negative terminal. Positive terminal will have high strength, high potential. Negative terminal will have least strength and least potential. So that only when you observe the symbol of cell, positive always it is represented with bigger line, negative with small line. So positive plus, which is big, because positive has greater strength, greater potential, and negative has least strength and least potential. So potential difference, simply to say, you know what is meant by difference. Height difference, they will say weight difference, like that. Potential difference. So here positive has high potential, negative has least potential, and if you compare between these, that is nothing but potential difference, represented with the letter V. Now what is potential difference means? Work done to move unit charge from one point to another. Guys, you see, in class 9 motion chapter, you have learned, if you take a ball, if you take a body, if it is at rest, if you want to move that ball, you have to apply some force. If you apply force, body which is at rest will be in motion. Same like that, in this circuit has conductor. So try to understand this concept. There will be circuit. Of course, in our house also all wirings, nothing but circuit. That circuits will have wires. Wire is nothing but conductor. All conductors will have free electrons. Free electrons. Or simply to say, those electrons you can call it as charges also. You can call it as charges. And now these charges, first of all, it will be at rest. When? If the switch is off. If switch is off, fan also will not rotate, because in a circuit, of course, wire is there. That wire is nothing but conductor. Free electrons will have charges. It will be at rest condition when switch is off. As soon as if you switch it on in the sense you are getting some power for your house from electricity board. Consider you have one small torch light or toy car. From where are you getting that power, guys? You have cell. This cell is providing some force. Because of the force, so what will be at rest? Charges. Because of the force, now charges will be in motion. Try to understand. Circuit consists of wire, nothing but conductor, will have free electrons. Those are nothing but charges. Always charges will be at rest. If you want to make the charges to be in motion, if electrons want to move in a conductor, simply to say current. You see current, what is meant by current? Flow of charge. If that, what is meant by flow? Motion, movement, right? Movement. If the charges want to be in motion, if charges should move, what you have to do? You have to apply some force, right? In circuit, who will give force? This cell will give force. Because of the force, that charges will be in motion. Motion means flow. Flow of charges, nothing but current. Simply to say, you are using cell to make charges move. So what is the main duty of the cell? Cell will provide force. Try to remember that. Cell will provide some force such that electrons will be in motion. Simply to say, current is produced. Current, what is meant by current? Current is nothing but flow, water current, wind current, air current, electric current, right? Now, cell is to produce force such that electrons will be in motion and current is generated. Now you see guys, to move, to apply force, if you are applying force in 9th class, again you have learnt one concept. If force is used, body is displaced. Consider you are using some force and body got displaced from this point to this point, from A to B, it got displaced. Displacement is represented with the letter S. F into S, when force is used, body is displaced. What you can say, work is said to be done. Work is nothing but force into displacement. Now simply to say, you are using cell to produce force and electrons are displacing from one point to another point. Simply to say, in a circuit, if you have bulb here, from here to here charges should flow, na, displace, na. So now if force is used, body is displaced, work is said to be done. That work done to move, unit charge. So if you are doing some work to move particles or particle from one point to another, one point to another means from this point to from this point. If you are making, that is nothing but potential difference or voltage. Potential difference is represented with the letter V, and V you can measure, you can calculate such that this is physical quantity. For every physical quantity there will be unit, and a SI unit of potential difference is voltage. Guys, if you didn't get it, once again you rewind this concept in this video and listen. Fine. Voltage V, and here also voltage volt, Alessandro Volta. In the honor of that one, that scientist, they have mentioned V, so that is also scientist name. You should not go with plural. You have to say 1 volt, 2 volt, 3 volt, 240 volt, etc. Now we got formula. Voltage or potential difference is represented with the letter V. Nothing but amount of work done. Amount of work done. For what? For what work you are doing? To bring charges from one point to another point. Consider you have a conductor from here to here. If you want to bring those charges, that is the amount of work done. You are using some force. That particle got displaced. Force into displacement is nothing but work. You are doing work. And if you are doing work to bring charges, nothing but voltage. V is equal to W by Q. Now, V represented with SI unit volt. So 1 volt is nothing but W means work. SI unit of work is joule. 1 joule by Q stands for charge. S unit of charge is coulomb, 1 coulomb. Now, if they ask you what is meant by 1 volt, you can say 1 joule of work is done for what? To bring 1 coulomb of charges from one point to another point. Nothing but voltage. Now voltage can be measured by using a device voltmeter, and voltmeter always it is connected in parallel. Ammeter in series, voltmeter in parallel, and while coming to ammeter, that ammeter you have to use the symbol straight line, one circle, another straight line, A, that is ammeter, and while coming to voltmeter, straight line, circle, another straight line, represent letter V stands for voltmeter. Right? So cell is the simplest device. Why it is used? To maintain potential difference, to maintain voltage. If you observe cell, so if you take small cell and if you observe that cap, this is positive terminal, that flat thing is negative terminal. What is the capacity of the cell? It is 1.5 volt. Like that. Now you see current always flow from higher potential to lower potential. Current means I. So here I told you current higher to lower, they told. Higher potential means positive, lower potential means negative. That's what I told. Because of higher potential, big line, positive. Because of least potential, small line, negative. Next, we have to learn about symbols. You are familiar. Cell, straight line, positive negative terminal cell, you have to represent positive negative. Battery means combination of two or more cell, positive negative. Again from negative there will be connection positive negative. Again from negative there will be connection positive negative, like that. Internally there will be no connection. Key, this is open, and if you put dot it is closed. Wire, joint, so here there will be one wire and one joint. Wire crossing, so there will be one wire. If wire is coming, you have to write like this, inverted C, reverse C, that is crossing. Bulb, how to represent straight line? One wrinkled line like this, and 0, that is bulb. It is off state. On state means you have to draw like this. Resistance, straight line, few spikes. Rheostat, so there will be resistor with one arrow mark, that is nothing but variable resistor. You know how to draw ammeter, you know how to draw voltmeter. You are done with that. And next concept is Ohm's law. It is quite simple. If you have circuit, you can use cell. So if you are using cell, what is produced? Potential difference. Simply to say voltage is produced. Because of the voltage, current is produced. So are you getting that point? In a circuit or in your house also, power source. From power source, what you are getting, guys? Voltage and current. So simply to say, voltage and current both you are getting in a circuit or in your house. So whenever, if all devices are turned off, if nothing is working, you should not say there is no current. So current is gone. There is no current in my house. There is no voltage. You should not say like that. You have to say power, because power is combination of voltage and current, guys. V and I, or V into I, is nothing but power. P is equal to V into I. So from now onwards, whenever all devices are working, you can say, yes, we have power in our house. There is no power in my school. There is no power in office. Like that you have to say. Now what is Ohm's law? Potential difference means voltage across 2 points of metallic conductor. If you take metallic conductor across 2 points, is directly proportional to current passing through the circuit. So guys, whenever you have voltage, definitely there will be current. Simple logic. And mathematical expression, V directly proportional to I. What is the meaning of directly proportional, guys? If voltage is increasing, current also will increase. If voltage is decreasing, current will decrease. Very simple concept. If you see fan in your house, beside that fan switch, there will be small regulator, isn't it? Small regulator you can find. Keep that regulator in 0 and try to observe the speed of the fan. No speed, 0. Keep that regulator in 1, try to observe the speed. Keep regulator in 2, observe the speed. 3, 4, 5, observe the speed. In each case, that speed will vary. Are you getting the point? Speed will vary. Why it will vary means 0 means very least voltage, 1 means just you have increased the amount of voltage, 2 some amount of voltage is increased, 3 it is increased further, 4 it is increased further, 5 means high voltage. If it is high voltage, so if voltage is high, current also will be high. If the current is high, speed will be high. Right? So voltage directly proportional to current, and the formula is V is equal to I into R. R stands for resistor, resistance. So R is resistance. And for voltage and current, there is a graph. So in examination, they might ask graph also. You will take x-axis current, y-axis potential difference you will take. So this is the point 0. You can consider 1, 2, 3, 4, 5. Here also you can consider 1, 2, 3, 4, 5. So you see, same concept. If it is 0, if you are keeping at 0, speed also will be 0. Now slightly just increase that regulator to 1. If you increase current value, voltage also will increase to 1. So you can plot a point here. If current is 2, voltage will be 2. If current is 3, voltage will be 3. Current is 4, voltage is 4, current is 5, voltage is 5. And if you draw a line, you will get one straight line, slant straight line. That is the indication that voltage directly proportional to I. If left hand side indicator is increasing, right hand side indicator also will increase. If voltage is increasing, current will increase. If voltage is decreasing, current will decrease. That is the meaning of directly proportional. When it will be directly proportional? When it is under certain resistance. Now, what is meant by resistance? It is a property of conductor, guys. Whatever conductor you take, copper, zinc, aluminum, iron, conductor, always you cannot get the same speed of flow of charges. You cannot get all electrons will be flowing in with the same speed. That speed will vary. It will vary. Why it will vary means because of the resistance, because of the property of the conductor. You take silver. In silver, current conductivity will be very good, very great. Silver. But if you can take gold, in that gold also conductivity will be very good. Take iron, take aluminum, take copper, it will vary. It will vary, right? So why it will vary means because of the resistance in the conductor. That is a property. All conductors will not conduct with the same rate. Okay. So what is meant by resistance means you can say opposing power. Opposing power. Now that resistance also you can calculate. So if it is physical quantity, definitely there will be one SI unit. SI unit of resistance is ohm. OHM, ohm. That symbol is 1 like this, like omega, ohm. So what is 1 ohm? Guys, here we got formula what? V is equal to IR. If you want R is equal to send that I that side, it will become V by I. V is voltage, 1 volt, by I is current, 1 ampere. So if 1 volt current and 1 ampere, sorry, 1 volt voltage and 1 ampere current is maintained, we can say that is 1 ohm. Rheostat is also nothing but a variable resistor. In the name itself, we can find variable. So we can increase, we can decrease, it can be regulated. So it is a component used to regulate the current. So that's what, if you see that regulator of the fan, you are regulating the current, simple. Now on which factor resistance of conductor depends? I told you if you take conductor, maybe gold, silver, aluminum, copper, whatever it may be. If you take, resistance will vary. Why it will vary? Depends on 3 concepts. Resistance directly proportional to length. So R directly proportional to length. So if length of wire is increased, so if you take big wire, resistance also will be great. Inversely proportional to area means R is inversely proportional to area of cross section. So if you take thick wire, resistance will decrease. Now directly proportional to temperature or directly proportional to temperature. If temperature is great, resistance will be great. Depends on nature of the material. So resistance depends on nature. You have to take this 2, and from this 2 you can get another formula. Here what we got, R directly proportional to L, R inversely proportional to A. If you club this, you will get R is equal to, sorry, R directly proportional to L by A. Now this is directly proportional. You have to remove and you have to add one constant. That constant is resistivity. Resistivity. You see, resistance is property of conductor. Resistivity is the nature. Okay, if there is resistivity, it will resist. Simple. Driver will drive. Painter will paint. Teacher will teach. Because of the resistivity, it will show the resistance. Are you getting that point? Because of the resistivity, it will show the resistance. If the resistivity is less, there will be least resistance. If resistivity is great, it will show great resistance. Now that resistivity is represented with the letter symbol rho, R-H-O, rho. So it is not like E, it is not like P in between. So don't write like E, don't write like P, it should be like this, curved, rho. Okay. Now SI unit of rho is ohm meter. Ohm meter. Guys, SI unit of resistance, ohm. Resistivity, ohm meter. Now these points are there, just you can read these points in the video itself, you can see. And coming to the next topic, resistance in series, resistance in parallel. Simple concept. If you are connecting, if you are combining, if you are merging devices side by side, if you are arranging it side by side. So take resistor, one resistor, second resistor, third resistor, like that. If you are arranging it side by side, this is called series connection. Series connection formula is, guys, I am not going into very deep. It is R is equal to R1 plus R2 plus R3. And while coming to parallel, what is parallel means? All similar terminals should be one side. Consider here we have a resistor here, second resistor here, third resistor here. So consider this is positive, negative, positive, negative, positive, negative. All positives at one side, all negatives at another side. That is parallel connection. And for parallel connection, you will get formula 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. R1, R2, R3 are name of those resistors. First resistor R1, second resistor R2, third resistor R3. I don't want to go into deep. So you can see this one, how you got this, everything, I think so you know it. What are the advantages of parallel combination over series? Always they will choose for parallel, they won't choose series. Why? Because in series circuit, when one component fails, the circuit is broken and none of the component works. So consider if you have series bulbs in series. So there are 3 bulbs in series. Consider if this second bulb is not working, remaining all bulbs will not work. Only first bulb will work, right? But in parallel, if one is not working, remaining bulbs will work. Different appliances have different requirements of current, right? Because fan will work with some amount of current, tube light will work with some amount of current, your washing machine, toaster, heater, it will work with a different requirement, different measurement of current, so that it cannot be satisfied in series. In series, that cannot be distributed. Total resistance in parallel circuit be decreased. So you can decrease the resistance and current can be regulated by using parallel, so that only in our house all devices are connected in parallel, not in series. Next concept, heating effects of electric current. Simply to say, by using electric current you can produce heat. Example, iron box, bread toaster, induction stove, water heater, these all concepts. By using these all the devices, by using electric current you can generate heat, means heating effects can be observed. Now heat can be represented with the letter E, stands for energy. Energy, E is nothing but power into time. So if you are sending some power for certain time, for example guys, you take one iron box, you have one iron box, connect that iron box plug and switch it on for 1 second and switch it off. You are sending power for 1 second and switch it off. Will that iron box be hot? No, it will not be hot. Now send for 2 seconds and try to observe. It will not be hot. Now send that power. Guys, power in the sense voltage and current. Send that power for 15 minutes. 15 minutes and switch it off. Now try to touch the, don't touch. Try to keep the iron box on some cloth. You can observe heat is generated. That is the thing. So heat energy is nothing but H or E, both are same, both are correct, no problem. H is nothing but amount of power you are sending in certain time. For certain time, if you are sending some power, if you are giving some power, if you are applying some power, that is nothing but heat. H is equal to P into T. Here E is equal to P into 2 you can get. And I told you what is meant by power. Power is nothing but combination of voltage and current, right? Now instead of, you see what formula you got, H is equal to P into T. Instead of this P you can substitute V into I. What you will get guys? H is equal to, instead of P, V into I into T. H is equal to VIT. That is also another formula. Now what is Ohm's law guys? V is equal to IR. Now try to substitute that V here. I mean here, what you will get? H is equal to, instead of V, I into R, IT, I into I, it is I square. At last you will get I square RT. So H is equal to I square RT. See how many variations you are getting. So what are the variations you got? First one, H is equal to power into time. From this, what we have got, H is equal to, instead of P, V into I into T you will get. Again from this, applying Ohm's law, H is equal to, instead of this V, IR into IT you got. Again I into I square. At last we got H is equal to I square RT. According to the question you can use the formulas guys. According to the question you can use the formula. Now Joule's law of heating. What is Joule's law of heating? Directly proportional to square of the current. So from this formula what we can get? 3 I R T. 3 are there, right? Now H directly proportional to I square, H directly proportional to R, H directly proportional to T. So what you can get? Heat directly proportional to current. So if you are sending more current, it will be more heat is produced. If you are sending current for 1 second in iron box, less amount of current is produced. If you are sending current for 10 minutes, more amount of heat is produced. If you are sending current for 30 minutes, more amount of heat is produced, like that. So directly proportional to Square of the current, H directly proportional to R. If high resistance, if it is there, resistance, heat is also high. If you take iron box, if you take induction stove, if you remove the panel, you can get high resistive coil. Because of high resistance, high heat is generated. H directly proportional to time. I told you, if you are sending for 1 minute, how much amount of heat you can produce? If you are sending for 10 minutes, how much amount of heat can be produced? If you are sending for 20 minutes, how much amount of heat is produced? When time is increasing, amount of heat generation also will increase. So from all this, you can say H is equal to I square RT. Heat directly proportional to current means if current is increased, heat is increased. If resistance is increased, heat is increased. If time is increased, heat is increased. Simple concept. Now these all electric heater, electric iron, electric bulb, electric fuses, everything will be using this concept only. And at last here we have to see electric fuse. What is meant by electric fuse? It is safety device that protects our electrical appliances. In short circuit or overloading. During short circuit or during overloading, we'll use that fuse. That fuse is made up of tin or alloy. Alloy means metal plus metal, combination of two or more metals. What are those metals? Copper and tin. Okay, alloy. Fuse is always connected in series with the live wire. In Matic effects of electric current, you can get that one, live wire. Fuse has low melting point because if some amount of voltage is increased, that fuse will melt. That will secure, that will be using, that will protect all our devices like that. Now power, I told you what is meant by power. Okay, how you got P is equal to V into I? That is also one concept, let us learn. Again, if you go to math, 9th class physics. So what is meant by power, guys? In work energy power, you have learned amount of work done in unit time is nothing but power. So if some work is done in time, nothing but power, work. So P is equal to W by T. Now what is work? You know voltage formula. If you go to top, what is voltage formula you got here? V is equal to, here if you observe, V is equal to W by Q. Do you remember? V is equal to W by Q. Now go here. So we know V is equal to W by Q. From this, what is W? W is equal to send that Q that side, it will become V into Q. Now, instead of W, what you can write? V into Q by denominator T. Isn't it? Now, what is the current formula? You can see here. Current formula, I is equal to Q by T. Here you can observe, I is equal to Q by T. So instead of Q by T, what you can write? I. So here, this one, P is equal to V into Q by T. This can be written as V into Q by T. Instead of Q by T, you can represent I, right? So P is equal to V into I. Like that you got power is equal to combination of voltage and current. Again, you know Ohm's law, V is equal to IR. So if you substitute V is equal to IR, P is equal to IR into I is equal to I, it is I square R. At last you got P is equal to I square R. Again, you know Ohm's law. Guys, I think I'm not that much fast. You see, we got P is equal to V into I. So this is the last concept, V into I. We know Ohm's law, V is equal to IR. Substitute that V is equal to IR here, it will become what? P is equal to IR into I, it will become P is equal to I into I, it is I square into R. Again, we know Ohm's law, V is equal to IR. From this, what is meant by I, guys? Send that R that side, it will become V by R, isn't it? Instead of I, you can substitute V by R, it will become P is equal to I means V by R whole square into R. It will become what? V by R whole square, V square by R square into R gets cancelled. At last you will get P is equal to V square by R. That's what we got here, V square by R. These all are conversions. According to the question, according to the given data, we have to solve numerical problems. To solve numerical problems, these are used. That's it. Apart from that, nothing. Now, at last, 1 watt, what SI unit of power? SI unit of power is watt. 1 watt is nothing but 1 volt into 1 ampere. So power that can be measured, that can be calculated. So if power is physical quantity, SI unit is watt. That is also scientist name. So there is no plural form, 1 watt, 2 watt, 3 watt, 10 watt, etc. So now what are the formulas we have learnt in this chapter? Once again, let us revise. We don't want all these topics. So first formula, current I is equal to amount of charges flowing in a circuit in a certain time, Q by T. What is meant by voltage? Amount of work done in bringing unit charge. We know Ohm's law, V is equal to IR. And at last, what concepts we got? Power. We next resistance, R is equal to rho L by A we got, and resistance in series, R is equal to R1 plus R2 plus R3 we got. Resistance in parallel, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 we got. Next formula, power, no, heating effects, H is equal to I square RT we got. How you got this one? We know H is equal to heat is nothing but power into time. This is one formula. H is equal to power is nothing but V into I into T. This is another formula. We know H is equal to I square RT because V is equal to IR and we are substituting we got. So guys, regarding the heat, if they ask any question according to given data, you can use one formula from these three formulas you got from heat, one formula you can use. And power, P is equal to V into I. Again, if you substitute Ohm's law, P is equal to I square R. This is another formula, and we know P is equal to V square by R. That is another formula. Regarding power, we have three formulas. So like that, these are the only formulas you got in electricity chapter. According to the question, you can do it, and please read textbook for total concepts. I didn't explain all concepts clearly. This is just brief. That's it in this lecture.